नमस्कार दोस्तों। तो आज का हमारा जो टॉपिक है दैट इज फ्रॉम aldehydes, ketones and carboxylic acid and question number 15. Our question is, how will you bring about the following conversion in not more than 2 steps? Very important question. There is always one or two questions from this part in the board exam, and it is also very important for competitive exams. Okay, first is propanone to propene. So first thing is you should draw the structures of both. See, in the first case we have propanone. Now propanone, we have to convert it into propene, right? Propanone to propene. Now, you know, propanone cannot be converted directly into propene, but propanol, if we have this part, propane 2-ol, that can be easily converted into propene by using concentrated sulfuric acid and on heating. And you know, to convert propanone into propane 2-ol, we can use sodium borohydride or lithium aluminum hydride. So that is a very simple question. It becomes very simple because we know we can convert propane 2-ol into propene by, but what is this? Beta elimination. What is this? Beta elimination, right? So by using this beta elimination, we can easily convert propanone. First, propanone should be converted into propane 2-ol, propane 2-ol. Okay, we can use sodium borohydride or we can use lithium aluminum hydride to convert propanone into propane 2-ol, and then propane 2-ol on beta elimination. What is beta elimination? Carbon attached to which is alpha carbon, and next one is beta carbon. So this is beta elimination reaction. Done. Next is ethanol to 3-hydroxybutanol. Ethanol into 3-hydroxybutanol. So you know we have ethanol or ethanol. Sorry, it is ethanol. Ethanol into 3-hydroxybutanol. See, we have ethanol and we have to convert it into 3-hydroxybutanol. That means we have to double the carbons as that present in the alcohol. Alcohol has 2 carbons, and in this is beta hydroxyaldehyde. Beta hydroxyaldehyde. कुछ याद आया? To convert aldehyde into beta hydroxyaldehyde, we have to use aldol condensation. That means if we have acetaldehyde on aldol condensation by using dilute NaOH, this is aldol reaction. We convert it into beta hydroxyaldehyde. 3-hydroxybutanol is beta hydroxyaldehyde, and you know alcohol can be easily converted into ethanol By using a mild oxidizing agent like, yes, any reagent that you know, we can use PCC. Okay, so by using PCC, what is PCC? Full form of PCC is pyridinium chlorochromate, right? So we can use PCC or even anhydrous CrO3. We can convert ethanol into ethanol, and ethanol on aldol reaction we get 3-hydroxybutanol. This is 3-hydroxybutanol, right? So this is the second part. Now what about third? Third is propanol into butanone. Propanol into butanone. That means we have to increase one carbon. First write propanol, CH3, CH2, CHO. Right? Propanol, and to convert it into butanone. Propanol into butanone, we have to increase one carbon. Now to increase one carbon, either we use KCN, and for KCN we need halide, and to get halide we need, yes, alcohol. But you know, in that case we get terminal CN, means CN is attached as terminal position, means we get carboxylic acid at the end on hydrolysis. But to get aldehyde or ketone and to increase one carbon only, we have to use Grignard reagent. Grignard reagent, that is methyl Grignard reagent, methyl magnesium bromide in the presence of dry ether. Keep in mind. So methyl magnesium bromide in dry ether, it leads to the formation of CH3, CH2, COMGBr and CH3, because CH3 is negative, MgBr positive. So O gets negative and carbon gets positive. Okay, so this is the product formed, which on hydrolysis leads to the formation of butane 2-ol. See, this is butane 2-ol, and on oxidation we get butanone. So this product in the presence of dry ether, after hydrolysis we get butane 2-ol and then butanone. So secondary alcohol, it is oxidized to butanone by, even we can use PCC or we can use anhydrous CrO3. Okay, anhydrous CrO3 or even potassium dichromate can be used. Okay, in acidified potassium dichromate can be used for secondary alcohol to convert into ketone. Done. देखो, PCC is best to convert primary alcohol into aldehyde, but it can be used to convert secondary alcohol into ketone. Okay, or we can use CrO3, or we can use acidified potassium dichromate even. Okay, next one. Next one is benzaldehyde to benzophenone. Benzaldehyde now we have benzaldehyde, and to convert benzaldehyde into benzophenone, what we do, we have to attach benzene instead of hydrogen. So better to go for oxidation first. On oxidation we get benzoic acid, and it can be carried out by strong oxidizing agent like potassium dichromate in acidic medium, and then use calcium hydroxide. When we use calcium hydroxide, it gives product like this. How is it possible? Say, first of all, we have benzoic acid and calcium hydroxide. So water is removed. So we get calcium benzoate, which on heating leads to the removal of calcium carbonate. So we get benzophenone, right? So what we do, we treat it with calcium hydroxide and then heat. So ultimately we get COO. Better to write it like twice calcium benzoate, and then on heating we get benzophenone. Calcium benzoate, benzoic acid, and from benzaldehyde. Next one is benzaldehyde to 3-phenyl propane 1-ol. Benzaldehyde to 3-phenyl propane 1-ol. Okay, so we start with benzaldehyde. Now we have to increase 2 more carbons. So to increase 1 carbon, we can use Grignard reagent. Even to increase 2 carbons, we can use, but in that case, we get OH group on the benzylic carbon, but we need OH on the last carbon. So we should use acetic anhydride in sodium acetate. When we use acetic anhydride in sodium acetate, we will get CH and COH. We get this product. Cinnamaldehyde, we get cinnamaldehyde. This is called Perkin reaction. Keep in mind, this is called Perkin reaction. Now, to convert it, see, double bond, we have to convert it into CH2. Means there is a reduction of double bond as well as reduction of carboxylic acid. Both should be reduced. Means we have to reduce double bond as well as COH. So keep in mind, this is a conjugated double bond, okay? So conjugated double bond and COH both can be reduced by lithium aluminum hydride. Otherwise, lithium aluminum hydride cannot reduce double bond, but if it is in conjugation, if double bond is conjugated, that can be reduced. And COH, you know, lithium aluminum hydride is strong reducing agent, so it can reduce it into alcohol. So this is 3-phenyl propane 1 propane 1-ol. Keep in mind, lithium aluminum hydride is a reducing agent and can oxidize aldehyde, can reduce aldehyde into primary alcohol, ketone into secondary alcohol, carboxylic acid into primary alcohol. Cannot reduce double bond, but if double bond is in conjugation with the ring, or it is a conjugated double bond, then it can be reduced by lithium aluminum hydride. Now say benzaldehyde to 3-phenyl propane 1-ol. This Perkin reaction is not given in our book. Okay? So benzaldehyde can also be converted into 3-phenyl propane 1-ol by using cross aldol condensation. See, we have to increase 2 carbons. Let us have CH3CHO in dilute NaOH. So this is cross aldol reaction. First, in cross aldol condensation, first of all, we get CH3CHOH and double bond CH3CHOH CH2CHO, right? Which on heating leads to the removal of water. So we get cinnamaldehyde. This is one step only, right? This is cross aldol condensation from up to this. Then, you know, even if we use H2PD, H2 nickel or H2PT, okay, whatever you wish to use, you can. Means catalytic hydrogenation simply. You know, double bond is reduced, even alcohol is, carboxylic acid is converted into alcohol. Okay, so in this way you can prepare. So both way you can use, either you start with Perkin reaction or you can do cross aldol condensation. Oh sorry, first here we get, but because you have to CH, right? Okay, and then on H2 PT we get the desired product. Done. So in Perkin reaction we get cinnamic acid. Sorry. But in cross aldol we get cinnamaldehyde. In Perkin reaction we get cinnamic acid, but in cross aldol condensation we get cinnamaldehyde, and you can use H2PD to give alcohol or lithium aluminum hydride, whatever you wish to use. Okay, here you can use both. So this is the way to convert benzaldehyde to 3-phenyl propane 1-ol. Next one is to convert benzaldehyde to benzaldehyde to alpha-hydroxy alpha-hydroxyphenylacetic acid, right? Alpha-hydroxyphenylacetic acid. Now see, we have to increase one carbon only, and at the same time OH should be attached. So what we do, we can use HCN in the presence of NaOH. pH should be 9 to 10. HCN and NaOH in basic medium, because HCN is a weak acid, so to get cyanide we will use basic medium. So in this way we get CH, OH and CN. Cyanohydrin is formed, right? And then cyanohydrin on hydrolysis we get alpha-hydroxy phenyl acetic acid. That's it. Now seventh is benzoic acid to benzaldehyde. See, we have benzoic acid to benzaldehyde. So we have benzoic acid and we reduce it, because if we reduce it, it converts into alcohol. So to stop up to aldehyde stage, what we do, first of all we chlorinate it. With thionyl chloride we get benzoyl chloride. SO2 and HCl is removed. Now benzoyl chloride can be easily converted into benzaldehyde by Rosenmund reduction. I think that H2PD in barium sulfate in the presence of quinoline acting as catalytic poison. Okay, so this is called Rosenmund reduction. So by using Rosenmund reduction, we can convert acid chloride into aldehyde, except formaldehyde chloride, that formaldehyde cannot be prepared by that method. Except that all acid chlorides can be converted into aldehyde by using Rosenmund reduction. Now eighth one is benzene to meta-nitroacetophenone. So we have benzene. Now benzene to meta-nitroacetophenone. So first of all, we can prepare acetophenone easily. This is very simple reaction from 11th standard. Acetophenone by using Friedel-Crafts acylation. Anhydrous AlCl3. Okay, CH3COCl and anhydrous AlCl3. So we get acetophenone, and acetophenone on nitration. You know, CO group is deactivating as well as meta-directing. So acetophenone COCH3 respect NO2 is attached at a meta position. So that is called meta-nitroacetophenone. Okay. Now last one, that is benzene. Now to convert benzoic acid to meta-nitrobenzyl alcohol. We have benzoic acid. So we have to attach nitro group at a meta position. So COH group is meta directing. So do nitration at this stage only. Now on nitration, we get meta-nitro benzoic acid. Now meta-nitrobenzoic acid, now COH group should be converted into CH2OH. So CH2OH we can convert by using lithium aluminum hydride, but that may affect NO2. That's why better to convert it into first COCl by using SOCl2, best chlorinating agent, and then simply use sodium borohydride, and on acidification, so we get CH2OH and NO2. So meta-nitrobenzyl alcohol can be prepared by using these reagents. Okay, so that's all about the conversions of aldehyde, ketones and carboxylic acid. Very important. From these three, it is 9 reactions, at least 1 or 2 should be asked in the board exam. Okay, so thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning. Jai Hind, Jai Bharat.